In this practice, we learn about different equipments and material, as well as we learn how to use micropipettes. This report shows our result from different activities that consist in collecting some specific volumes from a single sample and then presents our result. The spaces, equipment, and laboratory materials are distributed in an organized manner for the optimal performance in experimental practice. It is necessary to know their location, function, and care to ensure proper use and avoid accidents. Many of these considerations are closely related to the biosecurity aspects of a laboratory as well as the precision in the handling of the equipment. However, this practice may evaluate the good use of micropipettes according to the measurement of a certain volume of a sample. Some types of micropipettes are. Some advantages of this type of micropipette is that require
In Activity 1, 10 measurements of different amount of water, 2, 10, and 20 microliters were made with the micropipette P20. 20, 100, 200 microliters with the P200 micropipettes, and 100, 500, and 1000 microliters with the P1000 micropipette. In Activity 2, 5 records of each micropipette were made. 355, 40, and 4.5 microliters were added 3 times to a microtube and then recovered with micropipettes of P20, P200, and P1000 respectively. The data were recorded in tables, and the mean and the standard deviation were calculated for each measure. The mean helps to visualize the average value of each series of data. In this way, we can give an idea of how accurate was the pipetting technique of each measurement. And as can be seen in the tables, the average of both teams were similar and no reached the exact measurements. The standard deviation is a measure that indicates how scattered the data is with respect to the mean. With this measure, it can be identified that both the measurements vary from one another. And that is, the smaller the standard deviation, the smaller the dispersion of the data, which can be translated as constancy in the results. After the analysis of the data, it was observed that a measure was needed that would allow qualify the pipetting technique in general. So, from the data of Team 2, the standard error of each measurement was calculated and after each activity. The results were 2.147% error in the first activity and 18% error in the second.
The use of the pipetting technique allows dosing liquids quickly and accurately, because due to the high importance of the techniques, micropipettes of different sizes have been developed. In this practice, different measurements were made in order to learn to use them in a correct way, and this way be able to prevent errors that in the future damage the practice. Also, learn that the safe technique will not always be used. Some substances with high viscosity are sometimes used, and these are more difficult to work with using a micropipette. In addition to this, know the equipment of the laboratory, since it's vital for making use of this. Since each of these has a specific use and it always of implement in different ways. The results are shown in tables with the weight of each sample taken with each micropipette in 3 different measurements, with the lowest value, an intermediate value, and the highest value, and the same person was responsible for each measurement, so the results were more reliable. The highest and lower error margins correspond to different persons who practice in this practice, and this may be due the different knowledge and experience that each one has in the laboratory, as well as the good handling of the micropipette, since the good pipetting practice decreases the margin of errors. Some of the issues they consider this are the speed and the steady rate in the pipetting reduce the error in the total way.
The inconsistency in the results is attributed to the human error since both activities were carried out by different people. It is recommended that the activity be developed by a single person. In this way, the margin of error was a consequence of the skill and the experience acquired, as well as the use of good practices already established in the lab. So, the study and practices of the instruments is essential for a correct measure of substances. At the end of the experiment, the analysis shows that the error increases when the samples are taken closer to the maximum of the micropipette. When the quantities are smaller, the sample becomes accurate. The pipetting must be a correct technique in addition to a prior knowledge of the substance to be used, because not all have the same density or viscosity. In addition, at each opportunity, it is important to measure the standard deviation to observe how the technique improves with experience. Knowing the location of the equipment and substances help their better management and availability, since not knowing this could occur a delay of time to meet the objectives.